I want to give you a little bit of a change of pace. So we've got lots of different studies going on at the micro level where we're looking at decision making in very specific circumstances and are able to control sort of the environment and the context and manipulate things in a behavioral sense the way Renee and Glenn have described. And we're also doing things at a very large scale where we're running experiments with tens or hundreds of millions of people in the field, not in a digital laboratory, but out in the world where people are interacting on social media every day. And I'd like to give you a flavor for that kind of research that we're doing as well. I do want to answer this one comment about Facebook and YouTube, Facebook being the old school and YouTube being the new school. Even though I agree that there are a lot of things that are diminishing Facebook's impact there, throttling of the news feed and sort of the younger generations being more interested in video. Let's not forget the scale of Facebook. It is by far the largest social network in the world, and it is by far the largest consumer of engagement and time spent online. It's going to approach 1.5 billion people pretty soon. That's not something that we can ignore. I also believe that they will begin to integrate video more and more. So there's the sort of things that you have access to on YouTube, you're going to have access to on Facebook as well. So let me start with this. This is a slide that Rob Kane, who's the CIO of Coca-Cola, uses and has shared. This is 4 decades of consumer engagement from the 80s to the present day. Something to really sort of think about as you're going through your own business's strategy. In the 80s, we were focused on single messaging. In the 1990s, we were thinking about segmentation. Can we think about different types of consumer, different groups of consumer? In the 2000s, we were into customization or personalized messaging, personalization. We can track individuals online and give them specific personal messages. And really today, we are thinking about personalization in the context of the linked consumer. The consumer where we know who their social network friends are, we can engage them and have them engage their friends and vice versa, this socially linked consumer. So if we can put this in a really stark way for you to really think about the change that has gone on, if segmentation is the bleeding edge of where your company is in terms of marketing and targeting, you're about 2 decades behind. Okay? And that's not even thinking about 5 years out. That's just sort of like getting in line with the present day capabilities of marketing. Okay? So what we do here at the IDE is we analyze massive social networks of 10 or 20 or 100 million people to understand how information ebbs and flows in these networks, how social influence ebbs and flows in these networks, and what it means for consumer demand and consumer behavior. And really what we're talking about here is word of mouth. The ability for word of mouth from one consumer to another to change demand patterns and to change the effectiveness of marketing strategies and demand for products. And that's really social influence. It's one consumer influencing their friends to change their opinion about a brand or be aware about a brand or to buy a product that they maybe would not have bought before. And this is important for 2 different marketing strategies. Okay? The first one is targeting or prediction. Okay? If we're interested in understanding which consumers are going to buy a product that we are selling, having the preferences of their social network increases the predictive accuracy of our models tremendously. We can know with much greater precision who is likely to be interested in a product if we know if their friends are interested in that product. And all we need to execute that strategy, the targeting strategy, who do we send our message to, is prediction. All we need to know is to be able to predict which are the high likelihood buyers as a function of their social network. But there's another puzzle and strategy that also exists, which is about inferring causal behavior change. In other words, if your friend tweets to you about a product, how does that change your likelihood of buying that product? That's not about prediction. It's not about knowing your friend's preferences allows you to understand this consumer's preferences. It's about how can you transfer or change someone's preferences through messaging in a social medium. Okay? 2 very different things. What I want to spend my time on in the next 20 minutes is, what are the differences between these two things? How do you tease them out, and why are they important? Okay? The real challenge in understanding the difference between these two is understanding causality. Okay? And if you don't understand causality in the way human dynamics are working in the world's social network, then it's going to ask you to lead you to ask the wrong questions of your data. For instance, if you don't care about causality, you might see this graph and ask, is Facebook driving the Greek debt crisis? Right? It's clear from this evidence that it's true, right? More Facebook users, the Greek debt is rising in lockstep. This is a clear relationship. Or for instance, did the use of the baby name Ava cause the US housing bubble? Right? This is obviously true. Look at how those two things are moving in lockstep. As you use the name, the price index increases. As the name decreases, the housing prices are going down. Or my favorite, would M. Night Shyamalan start making good movies again if people bought more newspapers? Right? These are obviously ridiculous questions. But the point is that in order to understand why they're ridiculous, you have to understand the difference between correlation and causation. And that's the difference that's important for understanding when prediction is relevant or when inferring causal behavior change is relevant in a network. So what do I mean? In network science, this is known as the reflection problem. Okay? And really all this means is that in every single human social network that we have data on, we know that human behaviors are clustered in network space and in time. People who are connected tend to behave the same way at approximately the same time, tend to like the same things at approximately the same time. The real question is this because one person is influencing their friend, or is this because of some alternative explanation? And let me give you an example of an alternative explanation. A really good alternative explanation between the correlation of behaviors and preferences in a social network, besides one friend influencing another, is homophily. Homophily simply means that birds of a feather flock together. We tend to make friends with people who are like ourselves, and so my friend is going to have the same interests and preferences as I do. But that correlation doesn't mean that I influence them to have that opinion. It means that I've chosen to be friends with someone who has the same opinion as I do. Another really good alternative explanation is what's known as confounding factors. So here's a great quote from the famous sociologist Max Weber, who said, if you see a crowd of people all put up their umbrellas at the same time, you don't assume social influence is responsible, right? It's not that one person is saying, psst, hey, put up your umbrella. Psst, hey, put up your umbrella. It's probably a passing shower going over the crowd, and this exogenous shock that's correlated in space and time is causing the umbrellas to go up one at a time. Okay, but all too often in social network data, we make this mistake. We say, oh, people who bought this brand also bought that brand, and we assume that one person influenced the other to change their opinion about the brand, but it's probably because we have correlated exposure to external factors like the rain. So what does that mean in the real world context of buying goods? Well, if there's homophily in social networks and we make friends with people like ourselves, then we're likely to watch the same television shows or listen to the same radio programs as our friends, so we're likely to have correlated exposure to advertising. And that can create correlations in the products that we buy. That is not because of one friend influencing the other, but because of correlations in our exposure to external exogenous factors that are influencing and creating correlations in our purchasing patterns. So let me describe a few experiments we've done at scale that try to get at this problem and try to distinguish between correlation and causation and that are impacting business strategy. The first one is one that we did with Facebook with about 2 million people, and it was really about viral product design. Can we engineer products so they're more likely to be virally shared? Not in terms of a marketing strategy that you slap on top of a product, but can I change the way the product is built so that it's more likely to be shared once I release it out into the wild? So the way we did this is we did a large-scale experiment, 2 million people approximately, with a movie company that was releasing an app on Facebook. Okay? And this was a commercial-scale application where you could read about movies, buy movie tickets, read about directors and actors, like movies, share that like with your friends, and so on. Okay? And as people downloaded this application, we randomly assigned them to control and experimental groups. And for the experimental groups, we randomly enabled certain viral features, which I will describe in a minute. So this is an experimental group user with 3 friends, and those lines are solid to indicate that those channels are turned on. They can communicate with their friends in this way. This control group user also has 3 friends, and those lines are dashed, indicating that those relationships exist, but the channels have been turned off. And then we use this to observe the adoption and use of the application by friends of the control and experimental group to see, well, if we toggle this feature on, how does the application diffusion through the network change? So just to give you a clear sense for what we're doing, we have 3 versions of the identically same application that have very small differences with different viral features turned on and off. We release these 3 versions into the wild of the Facebook network, and we observe as they diffuse through the network, and we measure which application diffuses farther, faster, and so on, which one generates more engagement, and we can attribute that to the viral feature that has been turned on and off because it's been randomly assigned and because everything else about the application is identical. Okay? What do we find? The 2 types of viral feature that we test are personal invitations on one hand and broadcast notifications on the other. Personal invitations is just a series of buttons throughout the app that you can press, which takes you to a page where you can select friends from your Facebook network and send a personal message that says, hey, I really like this application. You might be interested. Here's a link. Okay? Broadcast notifications, the passive awareness campaign, every time you take an action on the application, it broadcasts that to your friends and says, hey, Sinan, for example, rated Terminator 2 3 out of 5 stars on this application. You might be interested in it. Here's a link. And that shows up as a notification in your Facebook account. Okay? And what we found was that personal invitations are about 3 times more effective per message than broadcast notifications. You're more likely to get click-throughs and adoption. This is, by the way, not on a click-through, but on an adoption of the application by the friend. Invitations increased adoption by 6% per message and 2% for broadcast notifications. And these invitations were very effective. They nearly doubled the global diffusion of the application in the network over the baseline case that didn't have this feature. But it was the passive awareness campaign that generated many, many, many more adoptions. Okay? And this seems counterintuitive. I see people sort of, their browser going, what's going on there? Well, in essence, what's happening is that the personal invitations are more effective per message, but there are many, many, many more broadcast messages going out, which in bulk, even though they're less effective per message, are generating more total adoptions in the network. And then you say to me, well, Sinan, you tricked me. First I thought personal invitations were the way to go, and then I realized that, that broadcast notifications get more adoption. But if you look at engagement with the application and likelihood to continue using the application 1 month, 2 months out after the application has been adopted, what you find is that personal invitations increase the stickiness of the application for the person making the invitations, and the broadcast notifications do not. Why? Because it matters who is joining us on the application. If the specific friends that I want to exchange movie information with are on the application with me, I'm more likely to stick with the application. But if it's a random person from my Facebook network who joins, then it's less likely to impact my engagement or or decrease my likelihood of churn. This is what economists call local network externalities. It's not just the number of other people who are on the application that matter, but it's the specific people and their relevance to you that matter for increasing engagement. The Harvard Business School, the Harvard Business Review did a really beautiful 2-page spread on this about what it means for strategy, and I can blow that up for you. And basically what they say is that for the passive messages, the pros are you get broader reach, more messages, and thus more adoption, and you reach a more heterogeneous population. Whereas for the invitations, they're personalized to be more persuasive, and it generates more user engagement, longer product use, and less churn. So you use this feature to spread the word widely about the product and generate adoption quickly, and this feature to build a loyal customer base to make the product sticky and to increase engagement. Obviously, you can toy with using these features in concert and so on. Okay? Now, we were happy with that study because it was a real large-scale experimental study of viral product design, but we wanted to go a step further and ask about individual people in the network. Could we identify individuals who were influential or susceptible to influence? And in this experiment, we randomized those passive broadcast notifications, so only a randomly selected subset of neighbors received the passive messages, which allowed us to measure who was influential and who was susceptible to influence. This is, for example, a result that we can get from a study like this or a randomization like this. This is your susceptibility to influence as a function of your relationship status on Facebook. Whether you say you're single, in a relationship, engaged, married, or you claim that it's complicated. Okay? If you're single, you're more susceptible to influence than if you don't report your relationship status. If you're in a relationship, you're even more susceptible than if you're single. If you're engaged, you're even more susceptible than if you're in a relationship. And if you're married, you're not susceptible to influence at all, apparently. If you claim that it's complicated, then you'll pretty much do anything anyone tells you on Facebook. I'm sure Renee and I could sit down and think about the behavioral reasons why this is true. We have had some armchair quarterbacking on what is going on here. I won't get into that, but it's quite fun. Once you have these individual measures, you can aggregate that up to the level of the network and ask, well, how is influence and susceptibility distributed over the nodes of the network, and what does that mean for diffusion? So, for instance, you can ask, are influentials simply surrounded by susceptibles, or do influentials cluster in one part of the network and susceptibles in another? What does this type of distribution of influence and susceptibility over the network mean for the diffusion process of a product going through this network? So for instance, these are just heat maps that show prevalence of people. Dark means not a lot of people. These white hot areas, lots of prevalence. This is your influence mapped against your own susceptibility to influence. And what we see is that highly influential people tend not to be susceptible to influence. People who are highly susceptible tend not to be influential, and there's this general trade-off between influence and susceptibility in a given person. The more influential they are, the less susceptible to influence they are, generally speaking. If you map your influence against your friend's influence, you find things like this. Here's a group of people that is high in influence and has friends who are high in influence. That might be a good group of people to target because their social network effects are 2 hops away in terms of social multiplier spillovers. This is a group of people who are highly influential but whose friends are not highly influential. So in seeking out who to target, you can use this information in terms of understanding how to affect the diffusion process. Now, I've been talking about behavior, but this also has implications for how people form opinions about products. And just to give you a little story, I went to a restaurant in New York called Dojo, and I wanted to rate it on Yelp. So I went to Yelp to go give my star rating, and there I am logged in. And I thought I had a pretty average experience at this restaurant. So the food was average, the service was average, ambiance and so on average. I'm thinking I'm going to give this thing a 3, right? 3 out of 5 stars sounds fair. So I'm going to rate this thing on Yelp, and when I get there to rate this, I see right next to where I would rate in bright red 5-star rating from Shar H, waxing poetic about the prices here are amazing, and oh my God, that fresh and amazing sweet and tart ginger dressing. How good was that? And I read that and I was like, well, you know, that dressing was pretty good, but given the prices, the food was pretty good for what you were paying, you know. So I gave the place a 4 instead of a 3. And then I stepped back and I said, well, that's not good. Because if I'm being influenced by this review that came before me, what's happening to everyone else? Is this a systematic thing? And what does that mean for the efficacy of reviews and how reviews are affecting future consumer demand? So we decided to run an experiment, which was published in Science, where we manipulated the ratings. We simply upvoted and downvoted items on a social news aggregation website like Reddit randomly and kept everything else the same. We just gave them a 1 thumbs up or thumbs down at the beginning and nothing for the control group, and here's what we found. The big result is that 1 positive upvote at the beginning increases the mean rating of the item by 25%. It shifts the entire distribution of ratings for those manipulated items to the right. And the reason for this is because Here's the positive herding. This is the likelihood of upvoting and downvoting for the first impression after the manipulation, not the total voting over the life of the product. There's positive herding on a positive manipulation. There's negative herding on a negative manipulation, but there's this what we call a correction effect for the negative. What does that mean? It means that when we see a positive opinion of someone else, it changes our opinion to be more positive. We say, oh, that item is probably better than I thought it was. When we see a negative opinion by someone else, we take it with a grain of salt and we're more skeptical. In fact, we're more likely to go in and say, that's wrong. I want to go in and correct that item and upvote it, even though I would have not voted at all if I hadn't seen that somebody else had downvoted something that I think is good. So we're more likely to go along with the positive opinions of others and more likely to be skeptical of the negative opinions of others. And this creates this massive increase in ratings for the positively manipulated item, whereas the negatively manipulated items look indistinguishable from the control group sense. So there's an asymmetric effect on positive and negative manipulations. What does this cause? It causes superstar effects. So positive herding snowballs into rating stardom. If we manipulated you randomly to get a +1 at the beginning, you were 30% more likely to exceed a score of 10, and that's no small feat because the mean score on this site is 1.9. So you sort of shoot off into the stratosphere of ratings with one perturbation at the beginning and then a path dependence of ratings in the positive direction for positive manipulations. On the negative side, this negative herding is neutralized by this correction effect, this skepticism of negative opinions. What are the implications? Well, you might want to encourage positive customers to rate and rate early. Why? Because they're going to influence the opinions of everyone else that comes after them. What does this mean for fraud prevention? Yelp has a black box machine learning algorithm that identifies and pulls out fraudulent reviews. But let's say that they're 100% accurate in their predictions of what's fraudulent and what's not. This still doesn't solve the problem because those fraudulent reviews have systematically seeped into the rest of the reviews that have come after them, right? So what does this mean for truly preventing fraud? You might want to think about whether your product is specifically susceptible to this kind of bias. Does it mean when you think in a larger sense of herding for sales or stock prices? And we wrote this during the 2012 presidential election, and I kept hearing poll results, Obama's approval rating, or who's going to win the election. And I couldn't help but ask myself, are these polls predicting the outcome of the election, or are they driving the outcome of the election? One final project I want to touch on is something where we're working with Nike to understand if exercise is contagious amongst consumers. So really, this is a program to use scientific research to harness big data and social influence analysis to encourage sustained fitness and athletics, user engagement with Nike products, and new user recruitments to Nike products and platforms, and also to help Nike understand how to use this data to engage the athlete. So what we have is 2 years of Nike Plus running data from 2009 to 2011. Here's all of the runs that people take daily in the United States. As you see, adoption of the platform is increasing, and you see some cyclicality. We don't happen to like to run much near Thanksgiving or near Christmas in this country. We prefer to be eating with our families. You also see some cyclicality at the weekly level, more running on the weekends than during the weekdays, and then during the times of day, more in the afternoon on Saturdays and Sundays. You have some running early mornings during the week, and then in the afternoon and at night during the weekdays. And if we could see that video, we have GPS time-stamped runs for a very large portion of this data. And here is running in New York City on a sunny Saturday afternoon. No, it's not running. You're still in presentation. This is my slide rather than the video. So you got to toggle the. And that's the slide again. You can see my name up there. If you're not able to show it, that's fine. It is kind of cool, though. Central Park lights up. Anyway, so here you would be able to see all of these, all of those individual lines are showing GPS-tracked runs throughout New York City, and in fact, throughout anywhere that we have data for that during the day. And you see, as the afternoon wears on, Central Park lights up, and you can really get a clear understanding of the granularity of the data that we have access to. We also have the social network, who is run buddies with who else, and for that reason, whose data is being seen by other friends' data. And so what we want to ask is, well, we have who runs, how they run, and we're thinking about who motivates them, and we have this network of Nike Plus users. We can ask, well, does one person's running behavior affect the running behavior of their friends? But again, we're faced with this problem when answering the question, is running contagious, of the differences between correlation and causation, which is sort of my stump speech. If friends tend to make friends with people who are like themselves, then marathon runners will be friends with each other, and people like myself will be friends with each other. And you'll have correlations in running behavior in pockets of the network and correlations in sitting on the couch in other pockets of the network. And you might think, oh, that's evidence of social influence, but not really, because it's about who we make friends with. So how do we tease this apart? What are we going to use? We can't run an experiment where we randomly force some people to run and see what that does to their friends. We have to be a little bit more creative. So what we need is something that's going to be correlated with your running behavior, but uncorrelated with your friend's running behavior, that we can use as a tricky exogenous variation to identify the causal effect of one person's running behavior on their friend's running behavior. What's a good example of that? It's the rain. Okay? This is running mapped against precipitation in New York City over time, precipitation in blue, and running behavior in green. And if you look closely, every time you have a rainy peak, you see massive drops in running behavior. Okay? When it rains, you run less. That's intuitive. Now, the tricky part of this is that we want to use something that's correlated with your running behavior but uncorrelated with the behavior of your friends, so we do this across geography. So basically what we do is we get all of the national oceanic and atmospheric associations data on precipitation and sun across the world, because all of our runners are across the world. We use that data to say, does a rainy day in New York reduce running in Arizona? If I live in New York and my friend lives in Arizona, the rain is not correlated that much between those two places, and I'll describe that in a minute. So when it rains in New York, I run less. Does my friend in Phoenix run less? Because if so, that can only be due to social influence, right? Because that's what's exogenously causing me to run less. Now, the problem with the rain is that it's not totally uncorrelated. In geography, we have, this is the rain in Chicago on the same day, and then the next correlations between weather in Chicago and weather in other parts of the country on the same day, 1 day apart, 2 days apart, 3 days apart. Essentially what that means is the weather in Chicago today is the weather in Boston tomorrow or the day after. So we have to take account of these correlations to understand what is truly exogenous between the two friends, and we use that to identify social influence. What do we find? We find a massive peer contagion effect. When you run more, your friends are more likely to run more and run faster and run farther. But it has some nuances. Friends who are very active are unlikely to influence friends that are inactive. Friends that are inactive are very likely to influence friends that are active. So what does that mean? The marathon runner running a mile longer is not going to get me off the couch. But if I get up and run today, you better believe that my marathon running friend is going to be like, oh God, I better get out there. Sinan's even running today, right? So these types of nuanced effects can help Nike understand how to engage the consumer and how to engage the friends of the consumer in encouraging each other to run. How? Well, maybe they could create contests for running. Maybe they could create groups where you share your running data and inspire each other to run. This is going to bleed over to engagement with Nike platforms. It's going to bleed over to engagement with buying Nike products. And it's also going to help the health of the people who are involved. We're working with the New York Times to understand how word-of-mouth conversations on Twitter affect consumption of the Times, what it means for the paywall, subscriptions, advertising revenue. We're working with MTV on voter mobilization. We've got a big project in South Africa using peer-to-peer incentives to drive HIV testing behavior. And we're working with an organization called Peace Text on de-escalating violence events around elections using text messages. And the same basic science of social influence is powering all of these different studies. So I will stop there and say thank you very much for your attention.